Hello and hi, and a very good evening. So today I'm going to be explaining about the uniform distribution. So the probability density function, which is the PDF for uniform distribution, is 1 over b minus a, which is a is the lower limit and b is the upper limit. Okay, and it is 0 for otherwise, which means that it is 0 if the x is not in the limit between a and b. Okay, and then the cumulative density function, which is the CDF, it is 0 if it is x less than a, which means the lower limit, and it is x minus a over b minus a for if the x is between the range of a and b, and it is 1 for x greater than the upper limit, which is b. So here is the moment generating function for uniform distribution. It is exponential to the power of tb minus with exponential to the power of ta over with tb minus ta. I'm going to be proving this one, so let's take a look. So for the first step, that if you want to find the moment generating function, you need to expect it the e to the power of tx. Okay, so here the expected, which means the mean of e to the power of tx. So you have, if it's the continuous case, for continuous case, you'll have to integrate from limit of the uniform distribution, which is a to b, e to the power of tx multiply with the PDF, which is 1 over b minus a. So 1 over b minus a is a constant, you can take it out, 1 over b minus a, and then all you got is e to the power of dx to the power to the respect of dx. I'm sorry. Okay. So to solve this inside, you must know that to integrate e to the power of dx, you'll get the guy back, e to the power of dx divided by t, which is you differentiate the power of the exponential. So you will get e to the power of dx over t to the limit of b and a. So solve this, you will get etb over t minus eta over t, and you multiply by the constant that you leave outside, which is 1 over b minus a. So at the end you will get etb minus eta over with tb minus ta. So this is the moment generating function for uniform distribution. Okay. So this is the first example that involves uniform distribution, which is the amount of time in minutes that a person must wait for a bus is uniformly distributed between 0 to 15 minutes. So the first question is the probability that a person wait fewer than 12.5 minutes. And the second one is mean and standard deviation of this question. So for question 1a, the question asks for the probability that x is fewer than 12.5. So to solve this question, it's just easy that you have to take the x 12.5 minus with the lower limit all times by PDF. So 12.5, when you minus 0, you'll still get 12.5 times with the PDF, which is 1 over b minus a, and you will get 1 over 15 minus 0, which is, this is the upper limit and this is the lower limit. So solve for this one, you will get 0.8333. Okay, so for question B, which asks for the mean and the standard deviation, you know that you have to find the expected of x. And for expected of x for uniform distribution, the formula is a plus b divided by 2. So you have the lower limit plus with the upper limit, and you have to divide it by 2. So you have 0 plus 15 divided by 2. So you will get 15 over 2, which is equivalent to 7.5. And for the standard deviation, you know that standard deviation is a square root of variance. So you have to find the variance, and you have to find variance of x, which is, the formula is b minus a squared over with 12. So you have the upper limit, which is 15 minus a, which is 0. You squared it and divide it by 12. So you will have so 15 squared divided by 12, you will get 18.75. But remember that this is the variance. So to find the standard deviation, you only have to square root 18.75, and you will have 4.33013. The uniform distribution is also applicable in the subject of ASC456, which is risk modeling. And here is the example for the subject. So a decision maker has current wealth W equals to 100 and utility expressed by UW equals to W power of 1 over 2. He must decide between the two options which will maximize expected utility. So the first option is uniformly distributed on 0 to 100. And the second option, the PDF of fx equals to 2 over 150 squared, 150 minus x, for from 0 to 150. So let's solve this question. You are asked to find the maximum expected utility for the two options. So option 1, which is, it is uniformly distributed between 0 to 100, and you are given the utility function, which is uw equals to w1 over 2, and you have a wealth of 100. So you first have to add up the 100 with the x, for as x will increase the wealth of the decision maker. So you insert the x in the utility function, you will have 100 plus x power of 1 over 2. And to find the maximum expected utility, you have to expect the whole equation, which is equals to e 100 plus x power of 1 over 2. So you will have to integrate, because it is uniformly distributed from 0 to 100. The lower limit is 0 and the upper limit is 100. So you insert the equation of uw 100 plus x power of 1 over 2, and you times by the PDF of the distribution. So you will have over with 1 over 100 as 100, minus with 0, you will get 100. Okay, you solve for this, you will have you solve for this, you will have 100 plus x power of 3 over 2 times by 2 over 3. So solving this equation, you will get 12.1895. So this is for the option 1. So for the option 2, it is given the PDF, which is 2 over 150 squared, 150 minus x, for x between 0 and 150. So it is the same as the first option. You have to solve this. You need to expect your utility function, which will be 100 plus x power of 1 over 2. So you have to integrate from, the limit is given from 0 to 150. So 150, the utility function, 100 plus x power of half, and times by the PDF, 2 150 squared, 150 minus x with respect to the x. And you solve for this, you you will get 500 over 150 squared 2 over 3 u3 2 minus with 2 over 150 squared 2 over 5 u5 squared, and insert the limits. You will get the answer 12.165. So the question asks for the maximum expected utility from option 1 and option 2. So the answer is 12.1895. This one is 12.165. So the maximum expected utility will be equals to the first one, 12.1895. Alright. Okay, so uniform distribution is also applicable on actuarial maths. So here is an example involving actuarial maths and uniform distribution. So find the probability of death for a person aged 20 where he must die between age 40 and 60. So following the de Moivre's law, which is the uniform distribution, with omega, which is the upper limit, equals to 80. So here's how we solve this question. So here you have a person aged 20 who must live until the age of 40, and he must die between the age of 40 to 60. So break down this equation. You will have 20, the probability of live until the age of 40, times by 20 with the probability of death after the age of 40. So for 20 p20, solving this, you will have omega minus x minus t divided by omega minus x, which is omega is the limiting age, x is the person's age, and t is the time. So insert the equation, and for 20 q40, you only have 1 minus 20 p40. You will get the same amount. So for this one, omega minus x minus t, just insert the omega, which is 80, 1 is with x, the h is 20, and minus with another 20, which is the time, over with omega minus x, 80 minus 20, times by 1 minus 20 p40, you will have 80 minus x, which is 40, minus with t, which is 20, divided by 80 minus 40, and you have the answer. And your final answer will be 0.33.
Hi, I'm Saiful, and I'm going to explain to you the basics of exponential distribution. Exponential distribution is almost like poison. It has the perimeter lambda, which means how many times an event happened in one period of time. So as you can see here, just like any other distribution, it has the probability density function, the cumulative density function, and the moment generating function. So for the probability density function of the exponential distribution is lambda e to the power of negative lambda x, and for the cumulative density function is 1 minus e to the power of negative lambda x, and the moment generating function is 1 minus t over lambda to the power of negative 1. So for the PDF and CDF, it is only for x greater than 0. Okay, so from the probability density function, if we want to find the expected x or mean, we can just substitute 1 over lambda, and for variance we can substitute 1 over lambda squared. So since standard deviation is the square root of variance, if we square root 1 over lambda squared, we can get the same answer with the mean. So for exponential distribution, mean is equals to standard deviation. So next I will explain the examples of exponential distribution in questions. Okay, for the first example, the question states that jobs are sent to a printer at an average of 3 jobs per hour. So from here we can get the value of lambda. So the first question, find the expected time between jobs. So this question wants the expected time of t between jobs. So you just insert the formula mean 1 over lambda, and lambda we just insert from the question, so we get 1 over 3 hours. We convert this into minutes, it becomes 20 minutes. So next question, find probability that the next job is sent within 5 minutes. Okay, first 5 minutes we convert to 1 over 12 hours because we want to be the same unit from the question. Okay, so from here we calculate the probability of the next job t time t is less than 1 over 12 hours, and from the formula we just put 1 minus e to the power of negative 3 which is the lambda, and 1 over times 1 over 12. 1 over 12 is the x from the question. So if we calculate this, we can get 0.2212. Okay, for the next question, suppose the number of phone calls arriving at an average of 3 calls per hour. So from the question we can just get the lambda as always. So the question is, what is the probability that no calls within 15 minutes period? So from the question it wants the probability that no calls. So from the formula we don't want that x is less than x, we just convert this to x is greater than x. So we get this formula e to the power of negative lambda x. So from the question we know that lambda is equals to 3 calls per hour. Like always, we just substitute lambda equals to 3 to the formula, and x equals to 15 because it wants the probability is less than 15 minutes per period. So just insert into the formula e to the power of negative 3 over 60, which means 3 calls per 60 minutes times 15 minutes, which we get from x. So if we calculate that, we can get 0.4724. Okay, for the last example question, on average the computer lasts 10 years. So like I said, lambda is equals to the event, how many times the event occurred in one given period of time. So from this question is 1 computer per 10 years. So the lambda is a bit confusing, not 10 but 1 over 10 years. Okay, so the question wants the probability that the computer lasts more than 7 years. Okay, we just use the formula that probability x is greater than 7. So e to the power of negative lambda, which is equals to 1 over 10 times 7 years from the question. Okay, so if we calculate this, we can get 0.4966.